So we're here to discuss another lecture topic that should have been presented in Chemistry 151, and you should have learned it in Chemistry 151. But chances are you might not have learned it in Chemistry 151. So again, that's the purpose of this class, and that's the purpose of me, right? So we're going to walk through a series of problems that's going to focus on molarity. Yay! Now, like I said before, if you think that you're comfortable with the term molarity and can solve problems and can do problems using this unit of concentration, then you probably can fast forward through all of these videos and go straight to the assignments. However, if you want to put me on 2 times the speed to see if there's anything new that I might bring into the picture, then so be it. It's up to you, however you want to handle it, because some of you maybe had a good instructor for Chemistry 151, and you do not need this review. It'll just be a waste of your time. So prove to me what you know, and then move on to the next activity in the lab module, or the lecture module. So, for those of you that might not have taken Chemistry 151 or didn't understand what on earth molarity was back in the day, then we can do that here. And molarity is just a unit of concentration. That's all that it is. So if I go to the bar and I order a mixed drink, I like my drinks pretty strong, especially when it concerns tequila or rum. So I'm going to look at the bartender and I'm going to say, no, this is too weak. You need to give me more. Or for those that might not hang out with me for a while and I take them to the bar and I get them a drink, I'll tell them to make it super strong, and they get it and they sip it and they can't tolerate it because it's too strong for them. They need to weaken it down. Well, the molarity of the alcohol is really high in my drinks and really low in theirs. Now, for you non-drinkers, maybe some of you are not 21 yet, right? I can relate this to Kool-Aid. I know, how boring is that, right? So some of you like to drink Kool-Aid, and you like to put tons and tons of sugar in it to make it super sweet. That molarity is really high concerning the sugar. Or some of you don't really like it that sweet. Some of you don't want all the sugar in your diet, so you don't put as much sugar into the mix. And that molarity is really low. That's all that molarity is, right? It's how strong something is. However, there's an equation that comes along with this, and that equation is a big capital M that's equal to a little m with an L. So the big capital M is going to stand for molarity. That's the concentration unit that we're after and that we're using in these example problems. The little m is going to stand for moles. And moles we've talked about already, right? You've already did some assignments with these. We've talked about the concept of a mole and what it is. And we're using mole in this equation. That's why they call it molarity, right? And then L is going to be for liter. Molarity is always referenced to in liter. That means every single time that you work these problems, you have to make sure that you are in a liter as far as the unit goes. You can't be using milliliter because the equation is not going to work out for you if that's what you do. Okay, so we need to talk about how to use this equation. What numbers go where? What type of math do I have to do? So let's do an example problem, right? Best way to learn them. So in this example problem, let's say that we need to calculate the molarity of a solution. How much solution? Well, let's say there's 1.5 liters. And in that 1.5 liter, we have dissolved 200 grams of magnesium chloride. How do we calculate molarity? Always start with the equation, right? What is the molarity? Oh, well, molarity is equal to moles per liter. And this number represents liter, right? So in this equation, 1.50 is going to go on the bottom. Now, this 200 number, where does that go, right? Well, it can't go here because this represents moles. Now, I've got gram. So I need to think, can I get mole from that number? Yeah, sure I can, right? We've talked about these problems over and over. I need to be able to convert the 200 gram into a mole before I can plug it into this equation. Once I do, then I can solve for molarity, but I've got to be able to do that first. So in order to go from gram to mole or mole to gram, I need the formula weight for magnesium chloride. Well, I'm not going to pull up the periodic chart. I think that you can find that information now without a problem. So magnesium's 24.31. You can find it, but I can't enter it in the right way. So 24.31 plus, and there's two chlorines, so 35.45 and 35.45. That gives me a 95.21 as the formula weight. So 95.21. All right, so I'm going to come over here to the side, and I'm going to choose a different ink color just to kind of do this calculation separately. 200 grams over 1, and gram is on top, gram on the bottom. I need to go to mole, and this formula weight says 95.21 grams in 1 mole. So I'm going to clear out my calculator, and I'm going to do 200 divided by 95.21, and I'm going to hit enter. And that gives me 2.10. So 2.10 moles of stuff is what I've weighed out. Well, now that I've got that mole, I can now put that number into the molarity equation, and I can solve for molarity finally. All right. So 2.10 divided by 1.50 equals 1.4. So my molarity of this solution is 1.4 molarity. That is all there is to molarity problems. It doesn't really get more difficult than that in our case. So if you can do this example, I think that you'll be okay on the assignments. But like I said before, it's about process here. So I want you comfortable with the process of solving these equations. So let's do another example. Let's calculate the molarity of a solution that's 500 milliliters. And let's say that we used 10 grams of NaOH to make that solution with. Okay, calculate the molarity. Well, I start with the molarity equation. Mole over liter. This time I wrote the word mole up on the top. Sometimes I do, sometimes I don't. It depends on how lazy I feel, right? So 500 milliliters. Well, I can't put that at the bottom. 500 mils, that's great and all. Yeah, we're going to be using that in the lab. We got 500 mil volumetric flask. But this equation requires liter. So I need to be able to convert that to a liter. Well, just in case you need help with that, over here to the side, 500 mils over 1, mil on top, mil on the bottom. I need to get to liter. So milli means a millennia, which is 1,000 years. So 1,000 mils is in a liter. So 500 divided by 1,000 is 0.500. So that's the number that goes on the bottom. I've converted my milliliter to liter, right? Okay, so next is this whole concept of gram. Gram can't go into this equation. I need mole for this equation. So I need to be able to convert 10 grams into mole. Gram to mole, just like up here at the top, I can do that. It's great. We've done problems after problems with them. But in order to do it, I need the formula weight for NaOH. Okay, so let's pull up the calculator. My sodium is 22.99, and my oxygen is 16, and the hydrogen is 1.01. So I'm going to get 40 even as a formula weight for the molecule. So over here, I'm going to do 10 grams of NaOH over 1, gram on top, gram on bottom, and I need to get to mole. Well, I can go from gram to mole if I know formula weight. Formula weight told me 40 grams per 1 mole. So I'm going to take 10 and then I'm going to divide that by 40, and I get a 0.25 as an answer. So 0.25 moles, and I've got 0.5 liter on the bottom. I've got all the pieces that I need to solve for molarity now. So I'll take 0.25 divided by 0.5, and I hit enter, and I'm going to get 0.5 as an answer. So 0.5 molarity. That is how strong that sample is. All right? So there's two examples using molarity, and that's about as complicated as these things are going to get, folks. So molarity shouldn't be a big issue here, especially if you practice with them over and over and over. So let's try another type of question. Let's say that I have 160 grams of NaOH, and that makes what ends up to be a 2 molar solution. Now, I call it 2 molar. Some people will call it 2 molarity. Both of those terms basically mean the same thing in a laboratory field. All right? So 2 molar solution, 2 molarity solution. It just really depends on who says it, tomato, tomato, right? Who cares? So if I've dissolved 160 grams to make a 2 molar solution, how much of the solution was made? No big deal here. This is just the same equation. I'm just solving for a different piece. That's all, right? So 160 grams, 2 molarity, how much? What's my volume? So the equation for molarity is equal to moles over liter. Well, how much solution? This is the piece that we're solving for now, right? I don't know the volume. That's what the question's trying to ask me to do. It says it makes 2 molarity, so that's the 2 here. So 2.00 equals something over L. That's the liter I'm going to have to solve for. That's the number that I'm after. So I should be able to get moles from the pieces of the puzzle. And I can. The problem gives me 160 grams, but I know good and well I can convert that to mole. That's not a problem. I'm going to do that over here to the side. So 160 grams of NaOH over 1, gram on top, gram on bottom. I need to get to mole. Well, I need formula weight in order to do that. So 22.99 plus 16 plus 1.01 is 40 grams. We did that before in the last example in 1 mole. All right, so I'm going to bring up the calculator. And there's 160 grams that was used. Well, 40 grams is 1 mole of stuff, so that gives me 4 as an answer. So that means that I have used 4 moles of sodium hydroxide in this solution preparation. All right, well, that's the number that's going to go here, 4. Now I need to solve this problem. Now, using the rules of math, if this is your variable, and you need to solve for that variable, you isolate the variable. You need to get it by itself. All right, so I'm going to multiply by L. That's in the denominator. That's divided by. So you do the opposite of. You multiply. And that cancels these out. So now I'm left with 2 times L equals 4. I need to get L by itself over here. That's 2 times L. So you do the opposite of. So divide, what do you want to get rid of? The 2. So I'm going to divide each side by a 2. So L is equal to 4 divided by 2, and that's a 2. So this is going to be 2 liters of solution. Now, what if the question said, well, how many milliliters is that? Right? All right, well, over here to the side, I can do that. 2 liters. Liter on top, liter on the bottom. I need to get to milliliter. Well, in 1 liter, there's 1,000 mils. So 2 times 1,000, that's 2,000 milliliters. Depends on what the question wants. Never forget those conversions. But that's another way that we can use molarity to solve a problem. So in the next video, we're going to continue on with some more examples. just to try to make you feel comfortable with the concept of molarity, because it is a common unit, and you need to feel comfortable, almost like riding a bicycle here, when it concerns these types of problems. So come back, let's review some more questions before you take a break and before you take a breather. That way you can go ahead and complete the assignment while it's fresh on your mind and move on to the next lecture topic.